Click for IB Biology. We're looking at epigenetics and air pollution, an example of epigenetics in operation in the population. There's a blank PDF of my presentation linked into the description. You can annotate that with your own notes. There's a 10-question with answers quiz for you as well, and even an AI prompt that you can cut and paste into your chatbot of your preference so that it gives you an individualized multiple choice assessment. So industrial pollution of this nature here, and the pollution and smogs that we associate with large urban conurbations, and indeed the smoke and air pollution associated with agricultural burning, is strongly correlated in the population with the development of lung diseases, and in particular diseases such as asthma and chronic bronchitis. The explanation of the effects of these pollutants on the lung tissue, and particularly of the upper lung tissue in the bronchial region, is that the air pollution which is produced brings about methyl tagging of DNA, of genes in the promoter region, and as previously explained, the DNA ends up tagging the cytosine bases, and particularly in the promoter regions, with the result of actually preventing the expression of genes through the prevented access of RNA polymerase. The kinds of pollution which are particularly associated with this DNA tagging of lung tissue is PM2.5, the polycyclic hydrocarbons, aromatic hydrocarbons, all associated with the combustion of fuels in vehicles, heavy metals from industrial processes, and these can either increase or fairly complexly increase or decrease the methylation of genes in the lung tissue. So the air pollution results in the DNA tagging of genes. These are the kind of things which cause that tagging, and the consequence of the methylation of genes is the altered expression of the genes, and this results in the production of inflammation within the lung tissue. It can also result in various immune response conditions, and this all starts to point towards diseases such as asthma. Let's spell that one again, asthma. So asthma is highly correlated with these types of air pollution. Cardiovascular disease is linked. Different forms of cancer are also linked within this. And the interesting thing is that there appears epidemiologically to be potential cross-generational links. So what I'm saying is that the methylation, so if we have parental DNA and it's methylated like this, then this can actually be passed on to the next generation's DNA, so that is carried across. But of course that would have to happen in the gametic DNA for that to happen. But there is some evidence that this is occurring. So air pollution is leading to the epigenetic DNA tagging of promoter regions caused by these types of pollutant here, resulting in a change in gene expression which has caused inflammation and immune response damages. Such diseases are asthma, cardiovascular diseases, and cancer. Now, attempts are being made to reverse this methylation through diet, obviously through trying to reduce this type of pollutant as well, of course, lifestyle, which may involve trying to avoid polluted areas, and then of course pharmacological treatments, drug treatments and therapy which may be possible. So this is the correlation between the air pollution in our cities and potentially and diseases which may be happening in a person and passed on to generations. Here's the link to the next video in our discussion on gene expression. There's the channel link. Here's the playlist.